welcome back to the channel. Today we having a new topic. We have a system design interview to design a Spotify. Spotify is the world's most popular music streaming platform, podcasting over 600 million monthly active users and 200 million paid subscribers. But how does it handle hundreds of millions of users and billions of music streams and deliver an almost seamless experience every day? That's exactly what we are going to break down in today's video. So, whether you are using Spotify, Apple Music, or Amazon Music, these platforms all share some fundamental features. They need to store millions of songs, deliver them seamlessly to users, manage user playlists, and provide personalized recommendations, all while ensuring low latency and high availability. Today, we will understand the functional requirements, the system architecture, and the key challenges involved in building scalable music streaming service like Spotify. First, let's gather the requirements. So we have two things. First, we have the functional requirements. In the functional requirements, we have search. Users should be able to search for songs, artists, albums, and playlists. Second, we have music streaming. So it's a real-time music streaming and it's a core feature, basically. Third, playlist. User can create, share, and modify playlists. Fourth, music recommendations. Personalized recommendations based on user listening habits. And lastly, ad-supported model. So for free tier user, ads play between songs, for example. Second thing, we have non-functional requirements. It will be scalability. Basically must handle hundreds of millions of users globally. We have low latency, which is songs should start playing instantly. High availability because we need minimal downtime and available 24/7, and global reach because use of CDNs like content delivery networks to serve audio files to users worldwide. Let's continue, and first let's talk about the capacity estimation. So, in your system design interview, it's important to go in this way. First, we gather requirements. Second, we make some capacity estimation. The first thing we need to talk about, I guess, our user base. So, I guess we will have about 500 million user, and we will have 100 million daily active user. Okay, this is first thing. Let me make this how to make this bigger, wider. Oh yeah, it's wider. The second thing, we need to talk about the average stream per user. So let's copy it, it will be easier. So average stream per user, I guess each user streams about let's say 10 songs per day. Third, we need to talk about the network bandwidth. Um, bandwidth. This translates to approximately let's say 5 petabytes of data per day, or around 58 gigabytes per second of bandwidth. So let's say that 5 petabytes, 5 petabytes BB. We need to talk about the storage as well. So the music catalog includes about 100 million songs. Let's say 100 million songs. Each averaging has like a 5 megabytes. So we're talking about around, I guess, let me think. I guess about 58 gigabytes, right? Yeah, it's 58 gigabytes. Let's talk about the caching. So caching frequently played in the frequently played songs can significantly reduce load. Caching the top 20% of songs, about I guess 40 gigabytes in size can cover, I guess, 80% of requests, to be honest. So, okay. So currently we have our functional requirement, our non-functional requirement, and capacity estimation. So it's a good idea to start in the high-level architecture overview of the system. So let's try to draw everything together. So first, let's say that we have the client. Oh, this is too small. Oh no, it's not too small. It should be. Let's say that we have a client. No, we have a client, and the client could be like a browser or desktop. Let's say desktop or mobile desktop or mobile. Let's make this way more smaller and mobile desktop and mobile, and let's make it okay, let's make it horizontally. Yeah. So yeah, this is, I guess this works well. So we have the client. The client could be a desktop or mobile, and I guess the client will send a request through a load balancer. So first, the client, the app runs on mobile or desktop and web as well, and communicates with backend APIs for search, streaming, recommendation, and offline playback. Second, we have the load balancer. The load balancer will distribute incoming client requests across multiple servers and instances, ensuring no single server is overwhelmed. After that, we have web servers or app servers. The app servers should handle client requests and direct them to the appropriate backend services. And then we have the backend services. I guess we will have maybe 4 of them. Let me try to first. I guess I need to make this look like that. Let's delete this one. And first, I guess we will have a user service. And I guess I want to make it like that. And the arrow, I don't like the arrow here. Let's make the arrow here. And yeah, I guess we have the user service, and the user service will have like it will be connected with 2 things, I guess 2 DBs. It will be connected. Let's change. Let's make the DB round, a round thing. It will be connected with a user DB, and also let's copy this and copy it here. And also it will be connected with a playlist DB. Let's put it here. Okay. So we have first we have the user service. I guess second we should have like a streaming service. Let me add another one here. And let's make this, it's aligned like that. Okay. The streaming service handles real-time music streaming for users. So the streaming service will be it will be connected with 2 things. Let's say okay, let's put the streaming service far in the end because it will be touching ton of things. Okay, so the streaming service first, it will be connected with, it will be talking with let's make this quite wide. Songs metadata DB. Songs metadata DB. and we'll talk on in further why this is important, and also it streams songs, so it will be should connected with a blob storage for audio files. So let's add a new one here. Let's say that we have a blob storage. Let's make it. It will be connected with a blob storage for audio file, and since we've talking about one of our requirements here is where is the where is that thing? One of our requirements is that we need low latency. I guess it's important to make sure that this blob storage is working with a CDN that will make sure the latency is way more reduced. So it will work with a CDN that streams to the user. And yeah. Okay, so after that we should have a search service. Okay, let's see. This search service has it's connected with I guess okay. Oh, sorry, I forgot to add something here. Also, the streaming service should be connected with a database. Let's make this round. It will be a popular song cache, for example. It should has like a popular song cache. Popular songs cache. It's really important to have this in the streaming. Okay, the search index, the search services. First, it will be should be has a connection with like a search indices database. DB. Let's make this round because we said that every database would be rounded, and also it will be connected with the. Okay, let's make. Can I flip this one? Because I guess if I flipped it, it will be way more easy. Um, no. Delete. First, make it like that here, and okay, this is. I guess this will be easier for us to. So the search should. Let's make the DB will be like here, okay, and the search will be connected with as well the metadata thing, and I want to make it like that. Okay, okay, this is great. As well, I guess there is another one here, which will be the recommendation service. I guess this will be the last service we add. Let's add it here. It will be recommendation service, and let's put it here, and let's put this quite up. No, delete, and change this to be like that, and make this here. I guess I might give this one different colors so it will be easier for us to let's make sure to give each one of them different colors so it will be easier for us to understand what's going on here. And the user, I'll give it this color as well. We give it this color, and Okay. So yeah, it's easier, I guess, with colors. It's easier to understand where is where and what is what. Okay, so let's try to talk again. So we talk about the services. We have the search service and the streams. We have the recommendation service that provides personalized music suggestion. And I guess we should add we should have like an ad service, and this service should delivers ads for free users. And this ad service will be actually in, well, let's put here. And first I want to make this like that. And okay, let's do it again like that. And it will be ad service, and this ad service. Okay. And this ad service should be let's just put the user and playlist db quite here with each other, so that would be easier. The ad service, I guess, should be connected with a blob storage, which is like a blob storage for ad files. Ad files, blob storage. And this one should be, give it different color, give it green. And the streaming service here, let's just give it different colors. Everything in this process that is responsible for the streaming, let's give it a different color. Okay, so I guess we are done with all of our services, and this is a good start here because yeah, it looks good. I guess it's important to talk about the storage next. So in the terms of the storage, we have databases like stores user profiles. For example, here we have two databases that stores users profiles, playlists, songs, metadata. I guess this one is a DB for songs metadata. Let's just put it here and make it really small again. I could make it round as well. That would be good. Let me make it down. Yeah. So we have songs metadata, and also search entities databases. We have about four databases here, as you can see. There are some blob storage. We have a distributed storage system. We're using AWS S3 for handling large scale storage of audio files and file ads. Okay, we have two blob storage here. And the content delivery network, or CDN, used to deliver large audio files effectively to users across the globe with minimal latency. This is the CDN we are using here. Also, we have a caches. We have a lot of caches. I guess we should have a cache for a song. I guess we should have as well cache for recommendation. We should have cache a lot for a lot of things. So caches are frequently accessed data, such as popular songs and recommendations, to improve performance and reduce the load on the storage and system database. We should also add some sort of analytics service. But let's just put this one here. Let's put it like that and give it different vibe. Analytics service, let's call it AS. So this one, well, let's call it analytics service. Analytics service. And this analytics service should be the analytics service, analytics and monitoring services track user engagement, system performance, and logs system health. It generates alerts when issues are detected and logs all system activities for troubleshooting, for example. Um, I guess so. We have we need to talk about next thing is to talk about the database design. It will be a big topic to talk about, which is database design, because we have a lot of entities. Because if you think about it, we will have, I guess, more than, I guess, five entities. We have the songs, we have the, what else we have? We have the songs, we have the users, we have the playlists, we have the albums, we have streams, we have recommendations, we have tons of things. So we will use both relational database for structured data like user profile and playlist, and NoSQL databases for unstructured data such as recommendations and search indices. For we might use a MongoDB and Elasticsearch for that things. And also we have a distributed storage for audio files, which is Amazon S3. So let's talk about the relational database ones. Let me add some. Can I add table? Because I need table. Let's see. Table. No, it's only icons. Okay, let's add here table. No, I need the table in one row. Okay. Okay, so let's start first by the user table. Let's say that this is the user, and in the user we will have, I guess, a user ID. No, no, make it white. White, please, thank you. We will have no, make this really big. We will have a user ID, and the user ID, I guess, it will be integer, or you can make it a UUID, like just whatever you prefer. Okay, I guess I don't like. Okay, I guess second we might have a name, and the name could be like a string or character. Let's call it string or var character. We have an email, and this email will be also string or to be type an email. We might have country. No, no, no. We have a country. We have like a subscription type because we have a app. No, oh no, no. We have like a subscription type. Subscription type. Subscript. Subscript. Oh no. Subscription. We have a subscription type. We have I mean, might have created it or deleted it. This is the user data. I guess we have, maybe we can have the song here. Let's add the song. No, no. What's going on here? Delete this and copy and paste. And let's add the song. This is for the song. And the song, I guess we will have, I guess, a song ID. I guess it will be integer. We will have a title. It will be a string. We will have artist ID. We could have like album ID. And we might have like a duration. And yeah, this is what comes in my mind. And also we can have like a file location and language for that song, in which language this song is. And no, no, no. What is this? What is this? Okay, so let's copy this and add it like that. Let's add here. Also, we might have like playlist, artist, and album. I guess this is the left. So let's say that. No, 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 no. Play list. And the playlist, I guess we will have also it will be a playlist ID, and we could have user ID, which is the owner of this playlist, and also we could have like a playlist name, and also we could have songs ID. Should this could be an array or like yeah, it could be an array of songs, and should be, and that's it, I guess, for the playlist. How to delete something here? I don't know actually how to delete. I guess there is an albums and artist. This is the end. Let's see here. This is will be the artist. The artist, I guess, it we have as well artist ID. Artist ID, and we should have name. Maybe we could have like a bio, and all of this will be strings and text. Maybe you have yeah, that's it actually. Delete this. Delete this and delete this. I guess next will be the album. The album. The album, I guess we will have the album ID. And we might have like a title as well, and maybe the artist ID, or maybe if there was more than one artist, it will be um, yeah, Ray. I guess that's it for the SQL schema. We might have a NoSQL database for unstructured data, like to store unstructured data for recommendation and for search indices. So we can use like a MongoDB or Cassandra, or could use Elasticsearch as well. In the recommendation, it will be like it will have a like in the recommendation we could create like let's create an object. Let's add a code block here to create the. I guess we will have like to be something like that. Oh no, sorry. It will be like a user ID that will equals like I don't know, a number like that, and we will have a recommendation song. Let's say recommended songs, and it will be array of the songs, and basically to be array of objects, and each object has like a song ID property that equals the ID of the song and the score of it. So how much does it is recommended? Like it's recommended. Let's say that it's recommended 0.099. So like just it's the biggest thing. We there is also search indices. The search indices, it will be as well NoSQL. So if we thought about the search indices, these indices are continuously updated as new content is added. I guess it would be have the indices will be title, the artist, the album, the yeah. This is what it will be like. We can create another one, another object, and we put song ID, title, artist, and album for the search indices. In terms of the storage, we store large volumes of audio and files in the blob storage. We can use a distributed storage system like AWS S3. S3 ensure high durability and availability, making it ideal storage for solution for serving large static files. Next, we need to talk about let's go to the content delivery network. Up. Let me see here. Okay. So the content delivery network, like we should use a content delivery network for distributing large audio file songs to users globally with minimal latency by basically by serving music from a CDN edge servers. Spotify ensures low latency music streaming experience for users across the world. Um, the files originally are from SS3 storage. The CDN should pulls this origin storage when a song it requested for the first time and caches it for future requests. We did talk about the caching layer, so I guess we did talk about the analytics and monitoring and in the analytics service. Um, we could talk about, I guess, the user flow from search to playback. So first, let's talk about the search requests. The user searches for a track. The app sends a request to the search service, which acquires the metadata database and returns the results. The playback request, there is a playback request. When the user selects a song, a play request is sent to the streaming service or streaming engine, and the streaming engine will play the song for the user. There is also a streaming setup. The streaming setup in engine uses a CDN, as you can see here, a CDN to deliver the audio with minimal delay, fetching it from a blob storage if it's not cached. There is also a playback. The user starts to listen almost instantly with caching and edge service optimizing and experience. So the entire flow needs to be fast and efficient, providing near instant listening experience. So let's talk about the backend services in deep dive, and let's start with the streaming service. This is the heart of Spotify. The streaming service handles real-time delivery of music to users, ensuring high availability audio and low latency content and the content is delivered from geographic distributed servers through the CDN. The second thing, we have the recommendation service. It generates personalized playlists using a combination of collaborative filtering and content-based filtering. The goal is to deliver suggestions that users will love based on their listening history and performance. And then we have the search service. It provides users with the ability to search for content across a vast catalog powered by Elasticsearch, I guess. The service maintains an up-to-date indices and index of songs, artists, and playlists, ensuring users get relevant and fast results. We need to address key issues and bottlenecks here. In terms of a system like Spotify must be scalable, reliable, and secure. So let's talk about them. In terms of scalability, we can use like a sharding and partitioning, split databases into specifically in these databases, the SQL databases. We can use like sharding and partitioning, split databases, and distribute across servers to handle large volumes of efficiency. We can use also auto scaling to automatically adjust server resources based on demand. In terms of reliability, we could use replicate database. We can replicate databases and cache data across multiple data centers to prevent data loss. We also should look at a graceful flavor, ensure uninterrupted services by rerouting traffic during server failures. There is some security concerns. We can use OAuth 2 for secure authentication and encryption for sensitive data, both in a transit and at rest. We could also use a rate limiting to protect a system from excessive API requests from a single client. So that's it, our system right now. And in conclusion, building a scalable and reliable and secure music streaming service like Spotify is not easy. From managing millions of users and billions of songs to delivering personalized recommendations and handling petabytes of data daily, the challenges are vast but incredibly exciting. I hope this video gave you a solid understanding of technical complexities involved And I hope this video will help you to ace your system design interview in the future. So that's it for this video, and thank you for watching. And if you like the video, make sure to subscribe and hit the notification bell so you never miss a video, and see you guys in the future.